Lesson 7.3, Triangles. We can classify or we can name triangles based on their angles or their sides. First of all, let's look at how we can name a triangle based upon the angles that we see inside of the triangle. In the top triangle here, we see that we have 1, 2, 3 acute angles. All of these angles are less than 90 degrees. So we would refer to this as an acute triangle. In the second picture, we see that we have a right angle in that triangle. So we refer to this as a right triangle. And then the third image, notice that we have an acute angle and a second acute angle, but this third one is obtuse. It's greater than 90 degrees. And anytime we have a triangle that has one angle that is obtuse, we refer to that as an obtuse triangle. So we can always refer to a triangle based on the three angles that we see inside. If all three are acute, we refer to it as an acute triangle. If one is right, we call it a right triangle. And if one is obtuse, we call it an obtuse triangle. We can also name a triangle based upon its sides. If we look at the top picture here, we have three equal sides. And the way that I know that is these marks here. These three hash marks indicate that all three sides are the same length. If that is the case, if all three sides of a triangle are equal in length, we call that an equilateral triangle. Let's see, I'm not spelling this correctly. Let's start that again. We call it an equilateral triangle. There we go. In the second picture, notice that there are only two sides marked as being equal. If that's the case, if two sides are equal in length, we call that an isosceles triangle. And then if we have a triangle where none of the sides are equal, and the way I know that is none of the sides have those little hash marks on them, they're all three different lengths, we refer to that as a scalene triangle. So when we're asked to classify triangles, we may be asked to name or classify the triangle based on the three angles inside. We may be asked to classify or name the triangle based on the side lengths. Or we may be asked to name it as both. We might call it an acute equilateral or an acute isosceles. Just depends on what directions we're given. When we look at triangles, it is important to understand that inside every triangle, the three angles inside will always add up to a total of 180 degrees. Every single triangle, whether it's acute, whether it's obtuse, right, scalene, isosceles, equilateral, it doesn't matter the type. Every single triangle has three angles on the inside, and those three angles add to 180 degrees. So let's take that idea that every triangle has 180 degrees and let's find the missing angle in each of these three examples. Let's start up here in the top left-hand corner. We'll call that number 1. We know that 60 plus 60 is 120, and 120 plus x must equal 180. Every triangle, the three angles add to 180 degrees. So we can find x by taking away 120 on each side, and we find out that x equals 60 degrees. If I was going to name that triangle based upon the three angles inside, I would call this an acute triangle because all three angles are less than 90 degrees. Let's move to the top right-hand corner. We'll call that 2. I have a 35-degree angle plus a 110-degree angle plus angle y. Together, all three must equal 180 degrees. So let's combine our like terms here. We have 145 plus y equals 180. We can subtract 145 from each side, and we find out that y equals 35 degrees. If I was asked to name this triangle, I would call this an obtuse triangle. And the reason is it has one angle that is greater than 90 degrees. Finally, let's move down here to the bottom picture. We'll call this number 3. We have a 45-degree angle and a 90-degree angle. So let's shorten our equation here. Let's go ahead and combine those like terms to begin with. 90 plus 45 is 135. So 135 plus z must equal 180. If we take away 135 on each side, we come up with an answer that says z is equal to 45 degrees. If asked to name this triangle, we would call this one a right triangle. The reason we would call it a right triangle is because it has one 90-degree angle, so it is called a right triangle. Now, what I'd like for you to do is I would like for you to try these two examples. Very, very similar to what we did a minute ago. I'd like for you to try these examples, pause the video, try them, and then turn the video back on and check your work. So in the top triangle, your equation would be x plus, you can go ahead and combine these two already if you'd like, x plus 84 equals 180. We take away 84 on both sides, and when we do that, we come out with an answer that says x is equal to 96. So the third angle in this triangle is a 96-degree angle. Let's look at the second picture. We have three angles. We have an angle that's x plus 7, plus we have an angle that's just x, plus we have an angle that's 127 degrees. And together, all three of those must equal 180 degrees. So let's combine our like terms. We have two x's, and then we have 7 and 127, which is 134, equals 180. Let's subtract 134 on both sides. And when we subtract 134, we end up with 2x equals 46. We divide by 2 on both sides, and we come up with x is equal to 23. So that means that this angle here is 23 degrees, and this one here is 23 plus 7, so this has a total of 30 degrees. If I was asked to classify these two triangles, the top one would be classified as obtuse because we have one angle that's greater than 90 degrees. The one on the bottom would also be classified as obtuse because we have one angle that is greater than 90 degrees.